Test review. All right, so I'm going to go ahead and get started. We are looking at the first question on your test review. It's asking you for the displacement. So rather than jump out and use all your kinematic equations, it already gives you your final and initial displacement. So all you're going to do is use delta x is equal to xf minus xi. So real quick, I'm going to move from the board and then show my video. Let's see, stop sharing. There we go. So we see that it gives us final position and initial position. In this case, we are going to look at the times. So when you see the times of 1.9 seconds and 2.63 seconds, the 1.9 is our initial time. So that means that that value will be our initial displacement. So xi is going to be equal to 12.4 meters, and xf is going to be equal to 0.77 meters. These numbers and plug them in. So we should get 4.77 meters minus 12.4. That means you're going to get a negative answer. So 4.77 minus 12.4 is going to give you negative 7.63 meters. That'll be your first answer. Every one of your short answers like that will always say answer in meters of such and such. And so you don't have, they're not asking you to put in a unit, you just put in the number. I would round to 3 sig figs unless it's telling you you're wrong, then go out to 6. Try it and it's not working. There is a no at least in which it will tell you that you need to put them all the way out. All right, so let me share the screen of the next one. So it wants you to tell it tells us now what is the velocity. So when we're looking at that, we're now trying to solve for the average velocity using the same information that we had up here. We're going to use the time now to help us and the displacement that we just found. So average velocity is going to be equal to your delta x divided by TF minus TI. I did that because we've already figured out delta x, so we don't need to redo that. It'll be negative 7.63 or whatever you find out for your value. To take our 2 times. In this case, time will you always put the bigger number first. 2.63 seconds minus seconds. It'll look like this. So that's so far how I identified that. I'm going to go ahead and do the math on that real quick. It is new for me each time I open up a new tab. So these numbers are different than what I've done thus far. And I find that, let's see, all that seems reasonable. I find that I get an answer of negative 10.5 meters per second. It's negative because we're going displacement, so the answer there will be negative. Let me double check myself here. 7 divided by 2.63 minus 1.9. Okay, so that should be your average velocity. On that one? All the viewers that I have, I've gotten 3 now, so that's awesome. If you have any questions, don't hesitate to use the or the YouTube on the YouTube channel. You can also send me messages that way. If you are, so don't hesitate to do that. On the YouTube channel. So just send a comment if you need to, and that'll help me. Well,
is that a 5 or a 3?
Okay, so right here's a 5.
So you did you subtracted first, or did you just
put it all on
your calculator?
If you're going to use, like on my calculator, I put it all in there. But if you're going to use a cell phone, what I would recommend is doing the subtraction first.
Oh, okay.
So like when I subtract 0.73, then I would take 7.63 and divide by 0.73, and I get my negative.
Thank you.
Make sense? Any other questions? Okay, the last one of this set, when you're looking at your homework, or I'm sorry, or the test review, I'll say that, I'll keep saying that, I don't mean to. Average speed. Calculate the particle's average speed during this time travel. Time interval, time travel. It's time traveling. So, speed is pretty simple. We just found the velocity. Okay? Unless you change direction, the velocity and the speed are the same thing. The negative speed. No, speed is absolute value. There will be no negative. So it'll be the exact same answer that you get, but it will be. So I'll stop presenting real quick, and I'll put down here that my speed is going to be 10 meters per second. Any questions about those? We good? Need to move on to the next one. Okay. My viewers, nothing? Yeah. Is there? Okay. I want to go over here. I want to talk to you about the next one. A plane. Cutting my face off in the camera. It's always really funny. One of the things you have to not forget is that you have the camera running. You know, unless I share this screen, if I'm sitting there talking, I could be picking my nose, I mean, scratching my head, I mean, whatever. Yeah. So I have to keep that in mind. It's a different mindset. Okay, a plane cruises at 236 meters per second, accelerates at 28 meters per second squared for 9 seconds. So what I would recommend you doing is looking through your kinematic equations. What you want to find is you want to find one that solves for final velocity in which you have time. Real quick, identify that. Which one has time? Yeah, you're right. Yeah, keep going that way. Okay, so I'm going to go ahead and put out what I found up on the board. So I'm going to go ahead and stop screen share. board. I found that I should use the equation VF to VI A. That's because in my problem I'm giving that my plane is cruising 236 meters per second, which is an initial velocity. My acceleration there is going to end up being 28 meters per second squared, 9 seconds. So to find my final velocity, I just plug those in. To help you out real quick, you can write down these variables. This was 236 second, 28 squared, and this was 9 seconds. VF is going to be equal to 236 meters per second plus 8 meters per second squared plus 9 seconds. Times 9 seconds. I think I said plus. 28 times 9. To get your values, I'm going to go ahead and enter this in. 236 plus 8 times 9. And I get an answer of 488 per second. So basically what I'm saying there, just so you understand and you realize, get out at 236, accelerating for 9 seconds, and every second I'm going to increase my acceleration 28. So if you wanted to take that back and look at it, okay? 6. All right, add 28. Another second went by, add 28. Same thing until you get 9. Tell you what your new speed is. 9 times. A heartache, we could just multiply 28 times 9 and add that in. That's how much we change by. Okay? Hopefully that makes sense of why we're doing that. It's not just some random method. Okay? The next problem is going to actually to solve for how far you traveled with the same information. So if you look at that, how far you traveled, what's the kinematic 1, 2, 3, or 4 should I use for the equation? 1, 2, 3, or 4? How far?
No, final velocity.
Okay, well, that's what we just used, right? Right? That's going to tell you how fast.
2.
1, 2,
3.
3. Far. X means displacement. Okay? Means displacement. On your equation sheet, write down that X means displacement. Right? So that you don't forget that. X means displacement on your equation sheet. What does A stand for? Acceleration. V is velocity. T is time. Now, I'm going to go ahead and show you how I would work this out on the bottom down here. Start with XF, that's your third equation, is equal to XI. So this is part 2. This right here was part 1. And we're going to then add in our velocity times our time, the acceleration times the time squared. That's the equation we're going to use. Okay? You're using the same information from up here. At the top, VI is 236 meters per second. I'm sorry, meters per second. That's right. Acceleration is 28 meters per second squared, and time is 9.
Initial.
Yes, and this is something I want to point out to you. It's fantastic. He said the initial displacement is 0. Well, if you look at your problem, it does not tell you that you started at this measurement. It doesn't tell you 0. initial displacement goes away. A lot of people have been plugging in their velocity there, and it's not. That's an xi. That's not a vi. The vi goes there. So you should end up having 6 meters per second, 9 seconds, plus 1/2, 28 squared, 9 seconds, and you're going to square that 9 seconds. Please don't forget, the only thing you're squaring is the 9 seconds. Plug that in real quick to see my math. I get 32.58, and that's going to be meters. Answers that I've gotten for this problem and seen for this problem, I see around anywhere from 15 to, I got 1,200 earlier today to 3,500. So if you've got an answer that's in that range, you're looking good. Make sense? Any questions from the crew here? Any questions from here? Let me double check and just see. So I've gone to YouTube to try to see if there was any questions from our viewers. It doesn't look like there is. I'm going to go ahead and move on to the next problems. All right. Just with the last 2 questions. I have withdrawn for the answer. Okay. So, or for the review, because when I was submitting my answers, doing the right math, exactly like the key was saying, every single time. Like, I don't want you to have to mess with that and try to figure that out. So we're going to move on. This is the next one. This is what the last couple look like. It's an automobile. And it gives you speed, it gives you acceleration, and it gives you a time. To find the final speed. By the equation you need first. To do that while I get my board set up here. Okay. Switch back to the smart board. Erase board. Our equation, it's asking for final speed. So we're looking at a final velocity problem. Remember, speed and velocity are the same as long as there's no direction. So I selected kinematic equation number 2. And I use this equation here. VF is equal to VI plus AT. Okay. Now we got to fill in our information. It says the initial speed is 3.89 meters per second. Is 4.3 meters per second squared, and the time is 4.2 seconds. So I'm going to plug this information in for this equation. Straightforward plug and chug information. We're just going to take that guy and put him here. 3.89 meters per second. I'm going to add in 3 meters per second squared times 4.2 seconds. Sorry. And notice that there is no square in this equation, so do not square this. When I put that math in my calculator,
Is that a negative dash? Like by part 1?
oh, I'm sorry.
Is that
This is just like a,
Okay,
this is
arrow.
part 1, yeah, like an
Okay.
arrow. All right. So I got, make sure I entered that in right. I got 21.95. That's what everybody else got.
on 4.3, do we square that or no?
No, and that's what I want to make sure. Anytime you have it in a unit, that's just a unit,
Oh, okay.
okay? In a little bit, you're going to have your t is going to be squared. The very next question,
That doesn't matter.
you will square it then.
Oh, okay.
If it said t squared, that's what you square it. If it had said second squared, then that's not a, you wouldn't square it. Okay, it's always on the variable itself. Okay. Answer to that question. Now there's a part 2. It wants to know what's the displacement. X. I'm going to use XF again. I do not have an initial displacement, so I'm going to leave it off to save writing. Tell me there's an initial displacement. That's why I'm leaving off the initial displacement. Okay. Take the information that I have up here and plug it in here. I've got 3.89 second times 4.2 seconds plus of 4.3 meters per second squared, 0.2 seconds, and we will square that. So I'm going to do 3.9 times 4.2 to 0.5 times 4 times 4.2 squared. Distance of 54.264 meters. Does that go with what everybody else found? Can you plug it in your calculator? Do you have any questions? Besides that? You have a homework that I've opened up, okay? If you did not finish the homework on Friday, it's still open. That's finished. And then you have this test review. I am going to grade the test review. I'm going to put both of those in as a grade into the system. I get you 2 good grades coming down the stretch right before your test. And then we're going to move on. That, you got one?
I got one about that.
Okay, what you got?
So I was trying to do this for my son, and I was trying to think, but I guess it wasn't doing it right.
Because you're on 6. Oh, let me see your work. Oh, okay. So key thing that I've seen people have problems with on this one is see how it says 0.096. If you go to do hang time, I'm going to time you when you leave the ground,
Right.
and then when you come back down. We only want from when you come back down. That's the only vector we want. Okay. If you've told me that the time for the entire trip down is this, is that right? Okay. Then what's this? It's half of it. So you got to divide that by 2 before you plug it in.
Multiply it by 9 times 8.
You'll square this guy after you divide it by 2. because it's going to be 1/2 AT squared. That's what the equation is going to tell you.
Math lab.
Because your final velocity is going to be 0 because you're at the top. Your position 0. So yeah, do that. And then 0.298 squared. So square that guy. Okay. Now multiply it times your acceleration times 5. So whatever your acceleration is.
Yeah.
5?
Well, 9.8 first.
This one?
0.5 comes from in the half, 1/2. 0.5 again. There you go. In the air about half, he had a huge about half a meter, or a height of about half a meter.
I realized
So
what
he was like this, about that high off the ground.
I realized what I did wrong for number 4 and 5.
Oh, you got it?
See, no, I did not.
Let me go over
I
here
got
and
a
pause.
0 for number
Let me go ahead and
4.
stop my broadcast. If you have any questions, send me an email, okay? Thanks, guys. Appreciate it.